Welcome to your Finite Math Lesson 1.2, Day 1. You're going to be learning how to model real-world situations with linear functions. Today we're going to talk about supply and demand. Next time we're going to talk about cost, revenue, and profit. In the real world, there are often pairs of variables where the value of one variable depends on the value of the other. So, for example, the height of a child is a function of his or her age, as well as other variables, but certainly a function of his or her age. So the independent variable age would be your x value, and the dependent variable height would be the y value. The height of a child is a function of age. One thing you need to be aware of or to be reminded of is that linear equations can be written as linear functions and function notation. So y equals 3x plus 5 can also be written as f of x equals 3x plus 5. The y and the f of x mean the same thing. Okay, so supply and demand. These are opposing forces in economics that are related to price. And from your text, there's a quote, typically as the price of an item increases, the demand for this item decreases while the supply increases. On the other hand, when the demand for an item increases, so does its price, causing the supply of the item to decrease. So these are opposing forces of supply and demand, and they're always at work in our society, working toward a state of balance called equilibrium, where demand equals supply. If we have too much demand and not enough supply, we have a shortage. If we have too much supply and not enough demand, then we have a surplus. So the forces are always going toward where the perfect price where demand equals supply. Economists consider price to be the independent variable in its relationship with both demand and supply. So the price is what is independent, and then the demand and the supply respond to that price. Unfortunately, Alfred Marshall, the economist who first studied these relationships, expressed price as a function of quantity demanded and price as a function of quantities supplied, even though it's considered to be the independent variable. So things are going to feel backwards for us. Our dependent variable, either quantity demanded or quantity supplied, will go on the horizontal axis, and our independent variable, price, will go on the vertical axis. All right, so suppose Brad Edwards, an economist, has studied the supply and demand for vinyl siding and has determined that the price in dollars per square yard, P, and the quantity demanded monthly in thousands of square yards, Q, are related by the linear function. This is the standard form that it's written in. Think of this D as just a label that this is the demand function, and just think of it as P equals 60 minus 3/4 Q. So the quantity demanded is related to the price, and that's how it's written. While the price and the supply Q are related by price equals supply quantity equals 3/4 Q. So P equals 3/4 Q. So find the price when the demand is 40,000 square yards of vinyl siding. So we're given a quantity and we're asked for the price. So the question is, which function do I use? Well, it tells us we're talking demand, so we're going to use our D function. So I like to write that as just D with a colon, and then P equals 60 minus 3/4 our quantity. Our quantity right now is 40, and that's in thousands of square yards. 3/4 times 40 is 30. 60 minus 30 is 30, so $30 per square yard is the price when the quantity demanded is 40,000 square yards. Now we're going to find the demand at the price of $45. So that means the quantity demanded. And we're given the price, so we're looking for Q. Again, we're working with demand. So I'm going to use my demand function. So I know P is 45. So 45 equals 60 minus 3/4 Q. So let's see. I subtract 60 from both sides, and I get negative 15 equals negative 3/4 Q. I'm solving for Q, so I divide by negative 3/4, which is the same thing as multiplying by its reciprocal. So negative 4/3 times negative 15, that is going to give me 20. Negative 4/3 times negative 3/4 cancels out, which was our whole point. So 20 equals Q. So 20,000 square yards is the quantity demanded when the price is $45 per square yard. We're going to find the price when the supply is 80,000 square yards of vinyl siding. So we're told what the supply is, so that's the quantity supplied, and we're being asked for the price. So we're going to use our supply function now, and we're going to plug in 80 for Q, and we're going to find P. So using our supply function, P equals 3/4 80. 3/4 of 80 is 60, so $60 per square yard when the quantity supplied is 80,000 square yards. Now we're going to find the supply, so the quantity supplied, available at a price of $60. So we're looking for Q, and we're going to use the supply function. So S is, our price is 60, equals 3/4 Q. Going to divide by 3/4, which is the same thing as multiply by 4/3. 4/3 times 60 is 80, so a quantity of 80,000 square yards is available at a price of $60 per square yard. All right, we're going to graph these on the same axes in your cast. You must adjust the window until you can see the intersection of the lines. It's going to be our equilibrium point. It's going to be really important, and in fact, in part F, we're going to find that. We're going to sketch the graph below showing your window. By showing your window, I mean you need to include the minimum Y value, the maximum Y value, the minimum X value, and the maximum X value, so we know what scale you're using. All right, first thing we have to do is re-express the functions where our calculator will know what we want. Okay, we're going to re-express Q as X and then P as f of X. So our demand function is going to be f of X equals 60 minus 3/4 X, where X is our quantity and f of X is our price. And our supply function is going to then be written as f of X equals 3/4 X. Again, instead of Q we have X, and instead of P we have f of X. That's so we can enter it into our calculator. So grab your cast. Seriously, if you don't have it with you, go get it, because this will help you remember better. And then take good notes. You may think, oh, I'll remember how to do this, but it would be good if you at least wrote down the things that I write down, and make sure you actually answer the question by drawing the graph once we get there. Okay, you want to choose B, graph. Okay, you want to go to your home screen and choose B, you want to graph. All right. You want to enter the demand equation for F1 of X. If it's not prompting you for F1 of X, press tab, and that should pop up there. So you're going to enter 60 minus 3/4 X. Okay, press enter. And then we're going to add the supply equation for F2 of X, and press tab to make F2 of X appear. I don't know why that didn't say F2 right there. Let me just change that for us. I don't want to cause anybody any confusion there. So for F2 of X, you're going to enter 3/4 X. Then press enter, and boom, you can see the F2 of X, but we don't see F1 of X. That's because we've got a problem with our graph. See how the Y max here is 7.39 and our Y-intercept here is 60? We need a bigger window. So what we're going to do is we're going to let the calculator try to fit the two functions in the window properly, and then see if we need to adjust some more. So the way we do that is we go to Menu, still in your graph, go to Menu and select Window, and then select Zoom Fit. And your calculator will do an okay job at getting both the functions in there. So here we go. We can see that the Y max is now larger than 60. It's up here to 75. And we can see both of them, but remember we want to see the intersection. See how they're kind of headed toward each other as we move to the right? We need to increase our X max, and my guess is kind of a lot. So we're going to hand adjust the X max. Okay, we're going to go in and tell the calculator we want to do that. So on this screen with the picture of the graphs, what you want to do now is press Menu, then select Window and Settings. Then tab down or arrow down, whichever one lets you move from item to item. Change the X max to 50 and press enter, or tab down and press OK. Once you do that, you should be able to see the intersection. Woohoo! There it is. Okay. Once you can see both lines and you can see them intersecting, draw this. Okay. Draw a little rectangle, show that you're going from -15 to 75 in the Y direction, -10 to 50 in the X direction. Sketch in F2, sketch in F1, and make sure we can see that intersection. Because guess what? For part F, we're going to find the intersection here. We're going to find the equilibrium quantity. That's going to be the x value. And we're going to find the equilibrium price. That'll be the f of x or y value. Okay? So we need to tell the calculator. You need to still be in your graph. You need to tell the calculator that you want to find the point of intersection. So we want to analyze our graph. So you're going to pick menu, analyze, and you've got like minimum, maximum, you want intersect or intersection. At that point, you'll be prompted for a lower bound, and then there's like a vertical line guide. Make sure it's to the left of the intersection, because the lower bound there means the lower x value where it can start looking. So it means really to the left of. Then arrow, after that, you'll be prompted for upper bound. Arrow the vertical line guide to the right of the intersection and press enter. And then the coordinates 40, 30 should appear on your screen. Okay, that means that the equilibrium quantity is 40,000 square yards of vinyl siding, and the equilibrium price is $30 per square yard. Okay. If you need to go back and review these steps, all right, if going back and looking at the video again doesn't help you out, come see me. I'll be happy to go through this process with you. Just make sure you can do it so that you can do the problems to try on your own and make a best effort at making sure you can do that so that you're ready to go and be able to do the board work and classwork when you get to class. Thank you so much for taking such good notes. I will see you in class. I hope you have a terrific day.